In this video, I'm going to show you how to use the Excel file to get implied volatilities using the Excel solver optimization tool. Now, when you open up Excel, then most likely you will not find the solver and you have to add it first. So typically the solver shows up in the Data tab on the right-hand side. Now for me, when I open Excel, it is not here. So if you have Excel for Mac computers, the way you do it is you go here to the top to Tools, and then you go to Excel add-ins. Once you press that, you see the different add-in tools which are available, and you want to add the solver add-in. Once you select it, you press OK, and it's going to show up here on the top right, and it's ready to use. Now, if you have a Windows-based computer, this process is a little bit different. What you will have to do is you go first to the Data tab, as what you see here, and then you go anywhere here on the empty gray area, and you right-click with your mouse. Now, with the Mac version, nothing shows up, but with the Windows version, a window will show up, and you can select Customize Toolbar. Once you click on Customize Toolbar, a new pop-up window opens, and on the left-hand side in the menu, you will find somewhere Add-ins. Once you click on the Add-ins tab, there will be a lot of stuff showing up, but towards the bottom somewhere, you'll find a drop-down menu, and it will say Manage Add-ins, and to the right of it there is a button which you can click which says something like Go or Customize or something similar like that. Once you click that, then a similar window will open which you see here on the Excel version for Mac. Again, you can add different add-ins. You want to select the solver add-in and press OK. Let me show you what you should not do, but perhaps you would be tempted to do. If you went to the Insert toolbar, here you actually see something called My Add-ins or Get Add-ins. And if you click one of them, you get a different window. My Add-ins, actually nothing shows up. But if you go to the store, you can search for add-ins. And probably you would search here for solver, but unfortunately you find a solver which is different from the solver which we want to use. This is actually some third-party solver which doesn't work very well. And you do not want to use that because you're not going to be able to get the implied volatility. This solver will not do a good job. Indeed, actually gets very low ratings, and my guess is that should be 0 ratings, and at some point hopefully Microsoft will just remove that from the store. So going back to where we were before, again, you want to be on the Data tab and you want to use the solver, which is this question mark with an arrow pointing to the right. Okay, once we have the solver, now what we want to do is choose our inputs first. In our question, the price of the underlying is 100, the strike price is 100, the risk-free interest rate is 2% per year, continuously compounded, and the time to maturity is 3 months, and there is no dividend yield. Now what we are looking for is the sigma, the volatility. And again, we're going to ask Excel to find for us the sigma, the implied volatility, such that the model price, the Black-Scholes call price, will be the same as the price at which traders are willing to buy or sell call options. So that would be the target or the market price is $4.23216. So again, we would like to find a volatility value such that the price of the European call option in the Black-Scholes model agrees with the price from the market. Now here I'm going to define the squared difference between these two prices. So once these two prices agree, then the squared difference is going to be 0. So what we're going to ask the solver is to minimize that square difference, or in other words, try to find a square difference which is equal to 0. So let's try this. So once you press solver, it first asks you for an objective. Here you're going to select that cell which you want to minimize or to be equal to 0. Once you have that, you're going to select here which cell Excel should adjust. So let me delete this again and select C6. So this is the value which Excel should adjust until that objective here is either equal to 0 or just minimized. Either way, it will go to 0. You could add some constraints. For example, you could say, well, volatility should be always positive. You're welcome to do that, but you will see that you also find the solution even without the constraints. Here you can choose different numerical optimizers. Typically, the GRG nonlinear approach works pretty well. Now, one important thing actually to do is choose initially a sigma which is somewhat reasonable. So choose something like 10%, 20%, 30%, but don't choose something extreme. Like don't choose 1,000% or minus some value, because that just doesn't make any sense to start with. Now once you have that, you press solve, and now Excel starts calculating, and you wait a little bit until it comes up with a solution. And so here actually it still is keep optimizing. It will actually tell you when it's done. A new window should appear. Now it says, okay, solver has converged. So convergence is good. It means it found an optimum, and you can press OK. So now you see actually the model price, the Black-Scholes model price, is really the same as that target price or the market price which you would like to match. And indeed, that squared difference is equal to 0. Now, what is the volatility which makes sure that these prices agree? It's basically 20%. So 20% plus some very small value which you can ignore. Notice that if I had the put option price, so here I choose it already such that it agrees with the model and the square difference is 0. But let's say I had the market price of the put option, and again, I didn't know initially how much the volatility is. So let's change that, let's say, to 25%. Now the model doesn't agree with the market price. I could use the same solver to solve for the put price. Now what I do is I change the objective to minimizing the square difference between the put model price from Black-Scholes and the put price in the market, or the target price. And again, I choose that C6, that's the cell, the volatility, which I let Excel change until I find a Black-Scholes put price which is the same as the market price. So now Excel is calculating again, and we wait until the pop-up window appears which tells us that it is done and it found a solution. So it is still calculating something. Let's see. Alright, it says it converged, so that's good. We say keep the solution and press OK. So now we see actually it gets really close to 20%, so it ignores any small value plus minus the 20%. And again, you see here the square difference now between the European put from the Black-Scholes model and the market price. They exactly agree, so the square difference is 0. And of course, now you can also do this for other prices in your model, right? You could, for example, take the square difference between the American call or the American put option price and the market price, and then run the optimizer again. So you can do that for different models, and the solver works exactly in the same way. Again, just to reiterate, the most difficult thing is to find the right solver, and again, to do that, do not go to the Insert tab to get these add-ins from the store, but stay with the Data tab and either go to Tools, Excel Add-ins if you're on a Mac, or right-click on the gray area in the toolbar, go to Customize Toolbar, then go to Add-ins, and then go to Manage Add-ins and press Go to get that window to add the solver. I think this might be the most confusing part, really, to find out how to add the solver so that you can actually get started.